All right. Welcome everyone to our fabulous panel here on visualization as storytelling. And let's see, do I have the name right there? Right, get it right. Once Upon a Visualization. And we have 6 excellent presentations this time around. And without further ado, I'd like to introduce Mara, who will talk about Delve into Earth's Past, a visualization-based exhibit deployed across multiple museum contexts.
Okay, can you see my screen?
Yes.
Okay, great, thank you. So yes, I'm Mara Solen, and on behalf of my colleagues at UBC, I will be telling you a bit about a visualization-based museum exhibit. So previous work in this field, in this area, has provided some really great insights, although all of them have been really focused on single contexts. And by context, I mean many aspects. I mean the room's theme, style, and size, the display type and size, the audience in the room, the other exhibits, and the intended use as communicated by signage or by museum staff. And when we investigate how people interact with our exhibits in these contexts, we will typically find a set of behaviors. But what if we took that exhibit and moved it into a completely different context and studied it again? Would we find the same set of behaviors? This is what we set out to find out with DELVE, which stands for Deep Time Literacy Visualization Exhibit, where deep time is a geoscientist term for the long periods of time of geological processes. And we deployed DELVE in 4 locations across 3 different institutions. We studied visitor behavior with Delve at these 4 locations and found that they differed quite a lot, which suggests that context does impact visitor behavior. But before I can really get into our findings, I want to show you how Delve actually works. So when a visitor walks up to Delve, they would see something like this. This blue timeline has 2 markers, one for today and one for the first event in the data set. On the top, there's a timeline, and this shows the full extent of the data set with a marker for the event you're looking at. On the left side, there's a media box with info on the event, including a description and a picture. And in the bottom left, there are a set of buttons. The main one is Explore the Past, which adds the next event to the screen. So hopefully you can see this okay. This is a very sped up video of how Delve works, showing the user pressing the Explore the Past button over and over. Events are added to the screen, and as they get exponentially further back in time, they're added to new timelines that are all stacked on top of each other and connected with these kinds of swooping lines. At the top, we see the timeline is finally moving. And once we get to the end, we see something like this, which is visualizing the entire data set simultaneously. We designed Delve to meet 5 project requirements, namely our deploy. So we needed to build collaborations since we didn't begin the project with any agreements to collaborate or deploy. And our curate, which is that we needed to enable museum staff to be able to create data sets since they're the experts on their museum's content and themes. We also have 3 visitor-facing requirements. First off, we need to engage visitors as sort of a gateway to any other goals we might have with the exhibit. Next, we want to inspire curiosity. And finally, we want to support our primary task of comparing varied magnitude time periods. Looking back at Delve, it's made up of many components, the biggest of which is a new idiom we call the connected multi-tier ranges. And this is the set of timelines that are stacked and connected to each other in the middle, taking up most of the screen space. As for our requirements, we used animation, interactivity, pictures, and colors to promote engagement. We used the textual descriptions and time labels to inspire curiosity. And we use the timelines and connecting lines to promote comparison. As I mentioned earlier, we deployed Delve in 4 locations, and while we had a different process each time, we always had a meeting where we showed off our prototype and got approval to deploy. And this shows success with our deploy. Similarly, we also successfully got museum staff to curate custom data sets for all 4 locations, showing success with our curate. Looking at our user studies, we did both an observational study and an analysis of our system trace logs. And overall, we found that we did meet our visitor-facing requirements. In terms of engagement, we saw long interaction times, lots of button pressing and text reading. For inspiration, we saw surprised and intrigued facial expressions and people discussing facts that they found interesting with others around them. And in terms of comparison, we saw people gesturing between timelines and overheard them verbally discussing scales and times and the differences between them. We also analyzed our data for differences in visitor behavior between these 4 locations. And we found that there were many differences, primarily in engagement, which, as a reminder, is kind of the gateway to any other goals. And this mirrors a paper from 2007, which looked at visualization lab studies in quiet lab rooms versus crowded corridors, and found that lab results can nearly flip in these 2 different environments. So along the bottom, we have our 4 locations. The first one, people were quite engaged. They spent a lot of time reading. They pressed the button many times. They looked through the whole data set often. In the second one, those who engaged similarly, but most people who walked up close to the exhibit were just walking by. And that's because this deployment was in a common space in a university building. And so many people were just walking by to go to class. In the third one, similarly, this was placed in kind of a rest area in the museum. And so many people were focused on taking a break or having a snack and weren't looking for things to interact with. And so in the fourth one, we moved, this was the second location in the same institution as the third one. And here we saw a lot more curiosity and engagement with Delve, although not as much as the first 2 still. Another big finding was in terms of process. We tried to follow VisTellAR et al.'s design study methodology, but found that there were some differences, and upon reflection, realized that was due to the trigger of the project, where VisTellAR et al.'s is triggered by a connection with collaborators who typically have data that they would like support in visualizing. Ours was triggered by a concept that we wanted to communicate or educate people on. And this led to differences in 5 stages. So the winnow and cast stages came quite late after we had implemented our prototype. The cast stage had some different roles. We have more of a viewer than a data analyst, and our domain experts were split into presentation and content experts. For the discover stage, we found that our tasks came from the authors and ourselves and from literature, as opposed to collaborators, because we didn't meet them until afterwards. We have this new stage, acquire, where we need to acquire data to fit our design, which is quite different from the standard design study, where you are typically designing to work with a certain set of data. And finally, in the deploy stage, we found we needed more in-depth field studies to actually validate our work than typical. So to summarize, we contribute our abstractions and requirements, the design and development of Delve, and the results of our studies. Secondarily, we contribute our new visualization technique and our alternative design study methodology. Please feel free to look at the paper for more details, and I'm happy to answer any questions now or on Discord or by email later. Thank you.
Thanks so much, Mara. That's really interesting. Please put your questions into Slido. In the meantime, I have a question. So first of all, it's great to see someone doing work on visualizations in context, and we don't have very much work about that and how it varies in different contexts. I'm wondering if, besides the environment of quiet versus rest and so on, or people passing through, if you have hypotheses about other different causes of other differences, like between rooms 1 and 2.
Yeah, I think there were a lot of differences. So some of them were, as you mentioned, due to how busy it was, but a lot of them are due to like the design of the rooms. So the first one is kind of in a place where most of what's in that museum is just a bunch of specimens with technical text kind of describing them. And it's kind of in a basement underground. And so it's quite actually dark in there. And I think that the people that go in there kind of have an expectation that they're about to read this technical text and get engaged with that kind of content. And that differs a lot from for example, the third institution where things are very bright, there's a lot of kind of colorful things around. It's kind of intended for kids or built for kids. There's a lot of the exhibits are really focused on, play and activity. And so I think that led to people having less of an expectation to interact with something more text-based or digital. And I think that has a big impact on the behavior, just how people what people expect to engage with when going into these spaces.
Okay, I'm not seeing questions more in the Slido, so I'm going to ask another one, which is,
Sure.
do you think, like, valence-wise, is it just it's okay if people don't use it in a certain venue because it's not maybe where they want it, or do you think the designers should proactively change the design to make it so people are engaged with it more in those areas where they're not?
Yeah, I think that if you're making an exhibit for a specific location, I certainly do think you should try to design it to be engaging for that context and that audience. But another thing to consider is just sometimes it's placed in the wrong spot. So in the third institution, we had initially placed it in this break area, but when we moved it into an area with other exhibits, it actually increased engagement a lot, even though we hadn't changed the exhibit at all. And actually, after submission, we had moved it to a third spot, which is in an area where the exhibit content is even more connected to the area, to the things around it. And while we haven't studied that yet, I suspect that there is even more engagement in that area.
Great.
So I
Okay.
think that, yeah.
Oh, sorry, we're out of time. So thank you so much,
Yeah, no
Mara.
worries.
Talk with Mara
Thank
more
you.
in the chat. And next up, our next talk is by Zheng, telling data stories with the hero's journey, design guidance for creating data videos. Take it away. Wei, we're not hearing you yet.
Okay, it's clear. Okay.
Yeah,
Hello everyone. Today
Wei,
I'm excited.
it's in you have it in the mode where we can see your notes.
Uh, it's clearly. It's okay.
Yes, that's great. Go ahead.
Okay. Hello everyone. Today I'm excited to talk about our research on using the hero's journey in data videos. As we all know, data storytelling has become more popular, especially in videos where we combine the visual and sound to explain the complicated idea about the data story. But what makes the story really engaging? That's where the hero's journey comes in. It is a classical narrative structure that we often see in movies and books, where hero goes through the journey of the challenge and transformation. Our goal in this research is to see how we can use the structure for data videos and provide particular guidance to help the designer and storyteller make their data video more impactful. The hero's journey was introduced by Jones Campbell, and it is a structure that can be broken down in three main parts: call to adventure, trails, and return. First, the hero is called to face the challenge. Then they go through the trails, and finally, they return home transformed, often with something valuable to share. This structure is used in many famous stories like Star Wars or Harry Potter. But when we talk about the data story, the challenge is figure out how to adapt this structure. We need to communicate data in a clear way, but also keep the people engaged, just like a hero journey keep people hooked. So here is our research motivation. We found the three main challenge. First, there is no clear guidance on how to use the hero's journey in data videos. Many people want to tell data story, but don't know how to use a structure like this to make it powerful. Second, it is not easy to know how to design the visual and sound for each part of the hero journey. Should the visual be the same for the whole video, or should we change them match the story emotion stage? Finally, although people are starting to use narrative theoretical in data storytelling, no one has really explored how to apply the hero journey in detail. Okay, here is our methodology. To address this challenge, we analyzed 48 data videos from a larger pool of 109 high-quality videos. We focused on how these videos use the hero's journey, especially looking at the narrative stage, sound design, and visual design. We want to see if they follow the hero's journey, and if so, how they use the visual and sound to tell the story. We coded each video, meaning we broken it down into different parts and analyzed how well it followed in the hero's journey structure. This helped us create a framework for how to apply this narrative model to data videos. Our main contribution in a design space. This is a particular guide for how to use the narrative, visual, and sound elements for data videos. We divided the hero's journey into 3 strategies: departure, initiation, and return. For example, during the departure stage, you might use the soft sound and simple visual to introduce the topic. But in the initiation stage, where the hero faces the challenge, you may use a stronger music or more dynamic visual to show the complicated for the data video. Finally, the return stage, upbeat music and simple visual can highlight the conclusion or key point. Additionally, our data video follows the hero's journey and its sequence structure. Integrates the stage like the departure, initiation, and return to enhance the coherence and the engagement. Okay, we look at how the part of the hero journey show up in 48 data videos and found the important steps in creating a strong story. Most common pattern in departure is DA plus the VE is totally 8 videos for the foster engagement and exploration. The most common pattern in initiation is DJ plus AI plus UT and plus RE is totally 9 videos, reflecting transformative challenge. And the most common sequence in return is GA plus IM or DID plus IM. It's totally 11 videos each, emphasizing the mystery and of the insight. Okay, here is our case study. Let's look at the case study in Vox video about Michigan politics. They use the hero's journey structure in the departure stage. They introduce the background with the Chrome voiceover and simple bar chart to set the sense. As the story moves to the next stage, where we see a deeper political data, the sound become more intense and the visual become more dynamic with the detailed data analysis. And in next return stage, they use uplifting music and visual to emphasize the conclusion, show how the political change have shaped Michigan. The combination of the narrative, visual, and sound makes the story both informative and engaging. Okay, we want to test how effective our design space is. So we conduct a workshop with 20 participants. We ask them to create their own data videos using the hero's journey framework. And some used our used our design space, while others didn't. The results were clear. Those who used our design space created a higher quality video. They were better at integrating sound, visual, and narrative structure. Many participants said that the design space made it easier for them to keep their videos engaging while still clearly presenting the data. Okay, here is an example of the storyboard created by a participant using our guideline, utilizing the hierarchical data set of SpaceX. Participants craft a data story of the hero journey. From the top button, the selection are the storyboard visuals, the guide used for the exploration, and the sound design displays according to the voiceover and sound effect and music. We also asked to export from the industry to evaluate all data created by the participants. They rate the videos based on narrative quality, creativity, emotional engagement, and visual design. The videos created by VisTellAR design space scored higher in every category. The expert particularly linked how the design space helped the participants create a clearly narrative flow with visuals and sound that match the emotional journey of the story. Okay, in conclusion, our research shows the hero's journey is a great way to shape the data stories, and our design space gave useful tools to help the storytellers use this method. By adjusting visual and sound for each part of the journey, you can make your data videos more interesting and easier to follow. In the future, we plan to make improving this design space and look at how it can be used for even more complicated data story, help storyteller bring their idea to life. Thank you.
Thank you very much, Wei. And please put your questions into Slido. And while we're waiting for others, I will start with the question. So first of all, this is really exciting work. And Sheila Carbondale actually gave a keynote earlier in the conference talking about the hero's journey and other narratives. And she said not that many people use the hero's journey, or it's hard to do. So I'm kind of curious what you think about those thoughts, and also what other narrative types you saw besides the hero's journey in your data set.
Okay. Before this work, we also to do something for the data video for opening, for ending, or before 2 or 3 years, we also the free talk primary data video structure. But I think the hero journey is really a typical interesting story style because it also focus on how the hero how a man to become a strong hero. So I think for the data set, maybe they will give people more idea or more idea to tell the story.
Yeah, okay, great. I have another question, which is, how could your design space apply to creating static infographics? Something I teach in my class. Can it help with that?
Okay. For the infographics, I guess maybe we can you can do the storyboard to the different picture. Maybe for the departure, initiation, and return. Maybe we can do the also otherwise for the video or picture also can tell the story. Yes.
Yeah, okay. It'd be fun to see you try to maybe refine your work to support that. Okay, well, thank you very much. I think we need to move on, please. Again, continue the conversation in the Discord. And next up, we have VisTellAR, embedding data visualization to short form videos using mobile augmented reality. And the speaker is Wei Tong.
Hello, can you see my screen? Okay, cool. So, hello everyone. So my name is Tong from Texas A&M University. I'm very glad to present our latest TVCG paper, VisTellAR embedding data visualization to short-form videos using mobile augmented reality. And this work is co-authored by Kento, Xigyo, Lin-Ping, Yuan, Mingming, Ting-Chuen, Pong, Huamin, and Meng. So short-form videos platform are getting more and more popular for sharing personal stories, as illustrated in the line chart, and also there's an example of short-form video platforms. And at the same time, so with more self-tracking apps and open data, so people have more access to their personal data, such as fitness data, and also other public data sets. So then we combining these two elements, we see the potential for people to share the short form videos embedded with data institute. So like daily steps when running to increase the credibility and expressiveness of their stories. For example, people may share a video of themselves running while mentioning the distance they have run so far in the week. However, creating and sharing these short-form videos promptly with embedded data visualization is challenging. Current work such as mass shots and commercial tools such as Flow Immerse aims to lower the barrier by introducing easy-to-use desktop applications with enhanced techniques such as machine learning. However, the current workflow is not optimized for in-situ creation and rapid data visualization embedding. The workflow is similar to this one. So we need to first take the video using a mobile phone, and then we prepare the data and create data visualization. Finally, we use the tools with post-editing techniques to add the visualization back to the video. There are two main challenges. So first, the offering environment is limited to desktop only, so which means that we cannot do the offering in situ, so while in the place that we take the video. And second, if the video did not have a good shooting angle or after adding the data visualization, there's some overlapping, so it's very hard to go back to the place to take the video again or fine-tuning the visualizations at that moment. Therefore, we want to build an AR mobile AR offering tool to help people to embed data visualization in short-form videos in situ. To do that, we first conducted a formative study with 10 participants using 3 design prompts to collect design requirements. So each of the design prompts emphasize different features and workflow that we introduced. And then we distillated the feedbacks and comments from the participants into the following design requirements. First is to integrate scene understanding for better blending the data visualization and reality, and then enable AR in-situ visualization configuration, allow quick dataset importing and visualization editing, and finally supports visualization fine-tuning and time control in the post-editing stage. So based on these 4 requirements, we introduced an AR enhanced framework of workflow. So compared with the previous approach that I introduced before. So first we moved the data preparation and offering stage before the video taking, such that user could create and embed the data visualization into the scene using AR technology before taking the video, for them to preview and adjust the shooting angle for the visualization. So by doing so, the users can really shoot the video by taking the data visualization as an object into consideration. So and then we based on this workflow, we built our prototype VisTellAR. So the prototype consists of 3 main components. First, we have the dataset preparation components, helping users to prepare the self-tracked data and provide some static data sets. And second, is the AR offering components. We deploy scene understandings, including object and plane detection, and also the device tracking to help users to put data visualization in the physical space easier. And then to ease the visualization offering process, we adapt DXR, XR visualization offering toolkits based on Nigar lights to reduce the difficulties in creating visualization by coding. And lastly, we have the post-editing components for the users to fine-tune the specification after really taking the video. So, and the behavior of the visualization as well. So as you can see in a short video, showing that the users could edit the visualization after taking the video. Okay, so to evaluate the effectiveness and the usability of our proposed applications, we ran a 2-day user study. So for the first day, we would just do the onboarding, introduction, and to our application and ask the users to try it. And then for each day at the nights, we would do a short interview to understand and see if there's any interesting findings from the users. And then day 2, the last day at the end of the at night, so we will do the debriefing interviews. So specifically, we design and adapt several questions on usefulness, satisfaction, ease of use, and ease of learning from the previous studies. And the results show that the participants highly appreciate the usefulness and the ease of learning of the proposed apps. We also observe many expressive ways to tell a data story, such as pointing fingers on the visualization, so passing through the visualization while running, and then flipping the books to show the visualization while mentioning the story, and then finally is to is to tell a story about 3D visualizations by moving the camera. We also analyze the videos generated by users in different perspectives. So due to the timeliness, please find the details in the paper. So in the future work, so we will study how multimodal interaction with data visualization can be supported even more during the storytelling, like gestures as explored previously by Brian et al. And then also physical object could be also considered. And then to allow users have more data for storytelling, we plan to integrate VisTellAR with more tracking applications like deploying CV techniques to counting objects like the number of people or even number of clothes, because that could help people to tell more story about their personal data. Lastly, with more powerful and lighter AR or MR glasses, there are more opportunities for people to express their story with Data Visualization Institute with more promptly and natural interactions using their both hands. So one of the limitations is that currently using mobile AR, the users needs to use one hand to hold their phone to take the video. With AR glasses, they can release their both hands to introduce more interaction with the data whilst telling the story. So to conclude, VisTellAR enables an easy workflow with useful features for people to embed data visualization in the short form videos for storytelling. We also observe that the new workflow introduces an expressive way to telling stories by using gestures, physical objects, and camera movement. Thank you for listening, and I am happy to take any questions.
Yes, everyone, post your questions to the Slido. Really interesting work. This is a great example of bringing visualization, broadening it, giving access to people, because lots of people make videos on their phones, and it's really hard, as you said, to put data in there. So do you have any feeling for kind of what sort of use cases will become really popular? Do you have any hypotheses about that?
During the formative study, we also asked the possible scenarios for the video takers to use data visualization for their mainly a few applications. The first one is education. So some short form video takers, they also take some educational videos such as teaching physics, or some even teach dancing. And in those videos, so adding visualization and even numbers, just numbers, could be very helpful and making the videos more intuitive. So one possible maybe future work is that we continued working on towards this direction. And the other way is to do some self achievements, as I mentioned in the first example. So showing fitness data in their stories could help them to be more self-confident and seeing the data, adding the credibility to show off their efforts in getting healthier. So I think this could be also one scenarios.
Okay, I do have a question from the Slido. Sorry to interrupt you. I thought I want to get to it. What other features for accessibility, both for standard users and those with impairments, do you plan to incorporate in VisTellAR?
Yeah, that's a very great question. So for at this stage, so we did not really think about accessibility, but it's very important aspects that we aims to incorporate in the future. So, for example, given that given that the AR glasses currently could also support many accessibility, like the third eyes for the disability peoples. So in the future, maybe we can incorporate AIs to help disabilities people to also create short form videos with data visualization they have.
Okay, thank you very much. I think we're out of time now.
Thank you.
So the next speaker is Leixian, speaking about WonderFlow, narration-centric design of animated data videos. And as he's setting up, I want to remind everyone to put your questions into Slido early because there is a delay before we see them. Take it away.
Okay. Hello everyone. I'm Leixian Shen from Hong Kong UST. I will talk about our data video authoring tool WonderFlow. Data video is a typical storytelling form that combines data visualization, animation, and audio narration. And it has many benefits like improving the engagement and enjoyment. And the data videos have also been widely used in various fields to facilitate communication. However, creating such data videos require much time and various skills. For example, users need to organize the data insights, record narration audio, design animations, and finally timeline all the components. So it's a very complex and difficult process, especially for the novices. So to streamline the process in our community, there have been many works have been designed to help create the animation unit or animated narrative sequence. However, they all miss an important factor in the video, that's audio narration. So there is no system that can integrate audio narration with animation in creating the videos. So to address this problem, we first perform an formative study to understand the workflow and the challenge for narration-enriched data videos. So in our study, participants frequently mentioned that they cannot preview the data video in real time because they need to use different tools and then combine the results. And they also feel inconvenient to align the narration and the animation, and also the complexity of animation design for visual components. And we also derive some design considerations from the formative study. The first one, we need to integrate all the features in a single tool and offer an easy-to-use interface for users. And we can ease the creation of audio narration by using the automatic text-to-speech techniques. And also, we can facilitate the animation design process by reusing the design patterns based on the underlying visualizing structure. And these design patterns can be made into reusable templates. And finally, we should support text visualization linking and narration animation synchronization to avoid the complex time alignment process. Based on these design considerations, we developed WonderFlow, which is an interactive authoring tool for data videos. It has several components. This is the narration editor. Users can upload their static text narration. And the text narration will be automatically transferred into audio. And this is the visual canvas. It displays the user's uploaded visualization and supported interactions. This is the animation effect panel. You can see that it displays some animation presets. Users can select from them. And finally, this is the timeline to show the established animation unit. And next, we can go through a system demo. So user have uploaded the text narration and visualization. So we just need 3 steps to create an animation. First, users need to select a text narration. Then the viewer canvas enter into the selection mode. Then we select the corresponding visual elements. These elements should be thematically linked to the narration text. Then the animation panel will be filtered to just show the appropriate animations. Then select one, then click. So we can the animation is established. We can play the effect.
In 2019, human caused
Yeah, so the link text and visualization and animation are automatically timelined. We can also fine-tune the duration and the start time.
in 2019, human caused
Yeah, then we can continue to make other animations. So due to time limits, we do
In
actually show the final
2019,
results.
human-caused and out-of-control fires burned 976,200 hectares of the Amazon rainforest. That's the third highest increase in the rate of deforestation in the Amazon's history. At a 30% jump from the prior year, second only to 1995, which was 95%, and 1998, which was 31%.
Yeah, with our tool, we can even create such data videos in 2 or 3 minutes. So behind this tool, there is a streamlined workflow. So users just need to create the text visual linking and then apply the animation. And all the linked components will be automatically timelined. So users can also review and iterate the design in a single tool. And another important module is the visualization structure with animation library. So we define a series of mappings between the involved visualization structure and the appropriate animation combinations. For example, in this animation, the pie chart sector will in, and the legend elements will fly in at the same time. So we can demonstrate. So in this example, we still first select the narration text. Then in the visual canvas, we just need to focus on the visual element that we want to animate. Then the animation preset will be automatically filtered. Then we just select one. Okay.
First, investors get their guaranteed cut.
So all the corresponding visual elements can be animated by just selecting one animation preset. You can see in the animation panel, we have predefined several animation presets for different behavior like enter, F size, and exist. And we also the animation are also for different chart types and also for different component levels. Yeah, users can also customize their list templates by add or delete some visualization structure. Yeah, this is his own template. Okay, then we move to the evaluation part. First, we produced an example gallery with different chart types and narrative topics. You can find more details in this link. Then we perform a user study with 10 novice users. So they need to perform 2 production tasks and 2 open-ended design tasks. All of them can complete the task, and on average, for the 2 reproduction tasks, they need 6 and 7 minutes. And for the freeform tasks, they need 5 and 7 minutes. And they are all positive about using WonderFlow. We also receive many good feedbacks. We also perform an expert interview. We invited 2 expert designers and 2 expert visualization researchers. So they were satisfied with the produced data videos in the user study and in the example gallery. They also tried our tool and recognized the importance of narration animation interplay. And we also received valuable feedbacks for potential application scenarios. For example, one expert said our tool can be more valuable if integrated into existing BI tools. And our tool can be used to prototype data videos for professional designers. And we also performed an interaction count comparison against PowerPoint. For the 11 videos in the example gallery, we counted the common interactions like clicking, brushing, and keyboard inputting. And our results show that WonderFlow requires relatively fewer low-level interactions. Okay, in the future, we plan to extend to leverage other tools, authoring capabilities, so we can integrate this interaction paradigm into other tools like the data-article visualization authoring and the data analyze tools. And we can also combine more automation techniques to further ease the process. And finally, we can enable multiple interaction pipelines. For example, in our existing pipeline, we start by selecting the narration text. And in the future, we can start by selecting the visual elements or by selecting the animation preset. Yeah, that's all. Thanks for your listening. Any questions are welcome.
Thank you, Leixian. That's a super cool system. And we have some questions here. So one question is, does the user have to use the auto-generated text to speech, or can they record their own audio?
Yeah, that's a good feature in our plan. Now we just use text-to-speech to automatically generate the audio. And in the future, we plan to let users to record his own voice, and then we can transform his speaking style into the audio. Yeah.
Yeah, I had that same question, so I'm glad someone asked it. The other question, with the discussion yesterday about the future of virtual versus hybrid conferences, should your tool get utilized by the community to build our VIS videos?
Oh yeah, yeah, that's interesting. I think our tool currently can produce some data videos, especially encoding some animations on the chart. So for more fancy videos, we also plan to incorporate some environment or characteristic and some other more fancy effect. And I think this can also be used to help us create our presentation. I hope our tools can be really used in the future for the VIS conference. Yeah.
Yeah. Well, I hope you keep working on it to put in those effects and these other things. I think a lot of people would want to use this. So thanks very much.
Yeah. Okay. Thank you.
Okay. So we're out of time. Our next speaker is Liu Ying, talking about reviving static charts into live charts. Because there are some technical issues on Liu's end, I am going to share a pre-recorded version of the talk, and then she'll be available to answer questions. Here we go. Hopefully this works.
Today I'll present the paper Reviving Static Charts into Live Charts. Charts are everywhere in our daily life. You can also see a lot of charts in social media like New York Times. Most charts there are static ones. They present limited information and their information capacity is limited. And I think they are not engaging enough to. So in this paper, we present live charts. Here is an example for live charts.
The title of this chart is Annual Box Office Earnings in North America in billion. The x-axis represents the year, the y-axis the earnings, and the legend distinguishes the adjusted and the unadjusted values. The chart shows that the difference between unadjusted and adjusted ticket prices is evident, with the latter typically resulting in a higher box office earnings number. Unadjusted annual box office earnings in North America are increasing over time, while the adjusted earnings are fluctuating. Moreover, the box office earnings in 2020 were significantly lower than the previous years due to the COVID-19 pandemic, regardless of whether they are adjusted to 2022 ticket prices or not.
Live chart seems good, but if you need to create one from static version and do all the steps manually, you need to extract data and visual encodings. You need to design animations and craft a narration. The whole process is time-consuming and tedious. So, can we automate the process of creating live charts? The answer is yes. Here is our pipeline for doing this. We start from SVG, and we extract data, get data insights, and we also create narration and animation based on insights. Finally, we combine all these things together to be a live chart. So we will detail the steps then. The first step is chart understanding. We start from chart element recognition. We need to first construct nodes and connect them using two types of edges, stroke and elements. Then we do the classification task with our model. Using this model, we need to know this element belongs to background or title or legend or mark or axis. We also need to know if it's like Y title or X tick. And after that, we need to calculate the data. We first need to know the legend data by match with the legend, and then we need to calculate the x-axis, x data and y data for line chart and by bar charts, and also pie chart is another condition. And after these things, we will get a labeled SVG, a new SVG including class, accurate data, and ID. Then we go to the second step, narration. High-quality audio narration can add informative context and direct users' attention. We use a structured narration from context to insights gradually. For data context, the first sentence is about chart type and title. The second sentence is about legend, encoding channel, and axis information. Here is an example for bar chart, indicating the context information. The first sentence, the title is, and the second sentence, the x-axis show year and y-axis show what's, and the also like two colors, red for Russia and blue for United States. The second part is about insights. We consider eight insights and use large language model to generate these sentences. Then we preserve only 2 to 3 ones based on importance. We want GPT to output a JSON file including all related informations. Detailed prompts can be found in our paper. Here we show an example for this bar chart. The chart introduces distribution, chain, and extreme 3 insights. Okay, after narration, we move on to animation. Animation synchronized with narration can stimulate both visual and auditory senses. To generate a proper animation, targets, effects, and interval need to be decided. Target means the SVG classes and IDs. Effect, we consider entrance, emphasis, and axis. We use the start and end word indexes as intervals. Since we use a machine to read narration, the speed is predefined. For contextual narrations, the target is title, axis, or legend. The entrance can be some simple ones like fade in, Y. The word interval are like from the first word to the 10th word for title, 11 to 18 for x-axis, accelerate. For inside narration, the target is matched via accurate data. The effect can be randomly chose from show box, change color, and for bar, it can be bar bars. For line, it can be show arrow. And the interval is decided by GPT using phrases. Okay, so after we introduce a pipeline for generating live charts, we may have a lot of questions like, is the chart understanding correct? Can live charts assist user in understanding charts? How about the effectiveness of our automatic generation workflow? So we conducted some evaluation, a recognition test for understanding, a user study, and expert interviews. Due to the time limits, here I only focus on the user study and show some interesting findings. We did a crowdsourcing study with 90 English-speaking users recruited from Prolific, and we use a between-subject study. Except from the first question, we also focus on in what way do animation and narration in live charts enhance the chart representation. We move on just to the findings, and the findings are positive. Users with animated and live charts say like animations. Narration is another crucial thing, since users with animated charts sometimes find it difficult to understand animations without sound. We also find some varying individual preferences. Some users don't like the leading role of live charts, and they have different opinions about speed. Something is too quick and something is too slow. Some users also commented about the challenge live chart may meet in printing and internet connection. That's all for my presentation. To conclude, the format of live chart is appealing, and we believe this format can be further improved with the increasing power from large language model and also the collaboration with humans. Here is Lu. Thanks for having me. I try to wear a SV t-shirt designed by myself. If you are interested in my work, please scan the QR code to see the homepage and more live charts on my paper homepage. I'm finding a postdoc all over the world. If you are interested in my work, please contact with me. Thank you.
All right. Thank
Hi,
you.
can speak.
Yeah, you can speak. All right, great.
Sorry. Sorry. Hi. Actually, you can just also share the video again because my last 3 minutes don't have any sound, and
Oh,
there is a live chart showing forever.
Okay.
Thank you.
There you go. But so we have a little time for questions while that plays. And so one question is, how was your experience using Prolific? I'm interested in running a crowdsourced study and was curious about the quality of the participant responses.
Okay. For me, I think the Prolific, my experience is good because I think for the first thing is that they are real English speaking because I'm not in English speaking country, and if I just find person from my country, so people may not very good at reading these charts, English charts. So in Prolific, they have some basic rules for this, and I think the quality is good, and also their reaction. I have done this I have shown these things in the presentation. They also prefer some very interesting insight that I didn't expect them to say. So I think it's a good experience.
Great.
And also it's very quick, very, very quick. You only need like 1 hour and you can have like 30 or 50 response.
Great. One really quick question. In your presentation, I noticed that all the examples were basic charts. Can you revive more complex charts?
Now we focus 3 types of charts: bar chart, line chart, and pie chart. In future, we decide to extend to other complex one also for glyphs. I do some work about glyphs, and I think glyphs in visual analytics systems, they are the one really needs the reviving. I really want to revive them, so I think I will do this later and to help these complex charts revive.
All right, thank you very much. Let's continue the conversation in Discord. And now I am going to introduce our final speaker, which is Jo-hee Kim, speaking about DG Comics, semi-automatically authoring graph comics for dynamic graphs. take it away.
Thank you, Chair. I'm Jui Kim from Ulsan National Institute of Science and Technology, and I'll be presenting our work, Digicomics, semi-automatically authoring graph comics for dynamic graphs. Dynamic graphs can represent various systems and phenomena through their evolving relationships. However, it is still challenging to extract meaningful stories from them and convey these stories to an audience. Comic-based storytelling has emerged in many studies as an effective method for narrating stories within dynamic graphs. Despite its benefits, several challenges remain unresolved. First, dynamic graphs are often large and complex. The multiple time frames they encompass make it difficult to identify key narrative elements. Since comics are character-driven, choosing the main and supporting nodes is a critical task that needs careful consideration. Effective storytelling through comics requires not only artistic skills, but also well-crafted narrative techniques to engage the audience. Lastly, it's important not to overlook the dynamic aspect. Capturing the temporal changes in the graph is essential for a successful narrative. We developed a graphs comics authoring tool called Digicomics. This tool allows users to select their desirable level of temporal granularity, observe and present stories from various perspectives, identify key characters and significant temporal changes, and use robust authoring features to support the creation process. To group similar snapshots and capture important changes, we designed a method called causality preserving temporal clustering. Before explaining the method, let me introduce the key concept. Each graph snapshot acts like a building block, showing the state of the graph at a specific time. A snapshot group is a set of adjacent snapshots that cover a certain time period. Our goal is to create these groups effectively by clustering adjacent snapshots together, while also giving users the option to adjust the number of groups. Traditional hierarchical clustering starts by grouping similar data, but it does not preserve the order. This is a critical issue for comics where the story needs to unfold in a specific sequence. To maintain causality, we compare the similarity of temporally adjacent snapshots. At each step, a snapshot group is regarded as a single snapshot to be compared. To achieve this, we developed weighted Joker similarity, which is computationally efficient and preserves label information in vector form. The clustering result is displayed in the summary view, where users can start with. They can define the number of panels by adjusting the depth slider. The number on the right reflects the number of the clusters created, shown in different colors. Once users create the generate button, each cluster is transformed into a panel. We use set operations to abstract the data over a time span. Snapshots within a cluster are aggregated using the union operation. To obtain the changes between two consecutive clusters, we apply subtraction to identify what was added and removed between time spans. We visually present an added subgraph with a neon effect and removed one with dashed lines, which are also customizable. As mentioned earlier, characters are key to driving the narrative in comics. Digicomics identifies the main characters that change the most over the time span of each cluster and highlights supporting characters with significant relationships. But at the same time, users can choose their own characters. They can explore trends in small line charts and inspect distances between adjacent graphs in the heat map. Multiple node attributes along with sorting and searching functions are available. Once the main character is selected, a new dendrogram is generated. Now, let's move on to the design details of comic template and interactions. The panels are arranged in chronological order from left to right and top to bottom. We determine the number of tiers by taking the square root of total panels, and each tier is divided into panels based on the time points represented in each panel. Captions are automatically generated and include a summary, major changes, and the most influential relationships. In this example, the caption highlights the network's contraction and the loss of collaboration. Digicomics offers a rich editing experience. The toolbar on the top helps manage the canvas format. Users can move, resize, and rotate the canvas easily. They can manually add the images, captions, and graph canvases with the brush tool, and even change the background image. The canvas can be moved forward, backward, or deleted if needed, while the Digicomics defaults to a forward-directed graph drawing. Users can stretch nodes to fill the canvas or maintain node positions across different canvases. The toolbox, which appears on the right when users click on comic elements, supports graph drawing. Users can modify node properties, such as color, size, stroke thickness, stroke color, highlighting type, opacity label, and label size. Images can be inserted into nodes, and multiple nodes can be grouped into bubble sets. The lasso tool simplifies multiple selections. When users want to manipulate based on the information, they can select rows from the supporting character table and press Edit to select multiple nodes. The style of graph elements can be edited as a group by assigning a class and defining it in the style sheet. Similarly, link and caption styles are customizable. Users not only use the provided narration template or modify it, but also automatically enhance it by clicking the rewrite button powered by a large language model. Tracking the evolution of community is essential for understanding the relationships between characters. To examine community changes centered around the specific character and compare them with others, we modify the Sankey diagram. In this version, community size is encoded with colors, and the evolution test is activated only when a character is selected. Users can easily display community cluster on the canvas by simply clicking on a community node. For more detailed information on other views, please check the paper. To validate the usefulness and effectiveness of our tool, we conducted a user study with university students and gathered feedback from various domain experts. Here, we would like to share several key points. Users had a positive experience with the system and highly valued the ability to discover new insights. Most participants found the summary view to be an excellent starting point for story generation. The community view was helpful in inferring relationships between nodes and events. Lastly, everyone enjoyed using the tool and expressed interest in applying it to their own data. We're happy to invite you to explore our paper and try out the tool on GitHub. Thank you for your attention.
All right. Thanks very much, Yohee. We've got a question in the Slido. Do you run into any limits of scale with your tool? How many nodes can comfortably fit in your views?
Actually, because it is we can use this in the web browser. We can afford to the number of the nodes that the web browser can afford to. So it's basically based on the user's own browser, but mostly because we use like actually, if there is no time limit, then I think we can render as much as we can, but it's really limited by the performance of the web browser. I think I can answer like that.
Well, I think one question might be, could you see all the nodes on this in the, not just process them, but would the interface allow someone to see all of the nodes if there was a large?
Yeah, I see. So as you can see on this page, there is like the B. Can you see the B view? It is like the filter that we can filter out the nodes if there are too many so that users cannot really explore it, then we can minimize it to like top 15 percent of the nodes that we want to see. Then we can just adjust the level of the bar and then click the generate button. Then it will just show the more important top 15% of the nodes on the view. So users can actually manage it. And if you set like top 100%, then you will see the entire nodes that it includes.
Okay,
Does
great.
it answer the question? Yeah.
Oh, here's another one just came in. What other data sets can we use with this tool? I don't know if they mean other than nodes and links, or what other sorts of nodes and links data sets.
So in our paper, we use like the collaboration network, which is from like VIS conference and then TVCG or any other. And there was another case study that we have written in the paper, which was national trade data. So the node was the nations, and the connection was like their trade network. So other than that, I think anything that can be displayed as network data, then we can just use it. For example, like social media data, or maybe it can be like entertainment data, which node can be like movies or the characters inside the movies and their relationship between the characters, like that.
I guess, yeah, adding on to that, the last minute we have, does this, I mean, you've cast a network as characters, you know, protagonists and so on. Does that work for all node data? I mean, if we had, I don't know, computer network monitoring data or something like that, does that make sense? Or is it only if it's like a social network?
Still, even though it is not really the character, I think it can be just work like play as a character. For example, as you can see in this picture, I just set the character as the subject. So even though it is not real character that can actually act, still we can show the relationship between different nodes, which can be applicable to any type of data. What else? Do you have any example that I can explain with?
I mean, I think you could kind of do that. You know, it's like you could say there's a network, a central hub in our computer network, kind of make that.
Yeah, right.
And then
so like computer 1 and computer 2 got the strong connection at the first, but it just reduces as the time passes. So we can just do everything with it if it is in the form of the graph data.
Yeah, great. And I guess the last question is, since you're calling it a comic, are you thinking about adding other kinds of visuals to it to kind of make it more like a comic strip?
Right. So as I explained in my slides, there is like the function that we can actually insert the images. So using that function, we can actually insert different kind of pictures inside our canvas. So if there is like specific like character or maybe like the background that they want to insert, they can do whatever they want. And at the end of their editing, they can actually export it in the version like PDF and PNG and JPG files, so they can use it whatever they want. Yeah.
Okay, great. Thanks very much. I think that's your time's up, and I want to thank all of the speakers for some really, really interesting work on storytelling. I want to thank the SVs for keeping this running smoothly. It's very complicated how this all works, so thanks to both of you. And I encourage everyone to continue the conversation in the Discord channel. So have a great afternoon, morning, evening, wherever you are. Thanks, everybody.